Hello, today we will be creating the movement of this bat enemy that you see on screen now. We will go over step by step how to create this type of enemy movement, as well as going over how to create random movement like this. And in the next video, we'll cover how to create this enemy's combat and take it from this to this. This is part 3 of the tutorial series where we will be covering this exact hack and slash game step by step in Godot 4. If you have any questions regarding errors, understanding, or anything at all, then please let me know in the comments and I will be sure to get back to you. Remember that this course is completely free, but if you want to help support me a little more, then a link to my Patreon page will be linked in the description below. Your support truly means the world. Thanks, and remember to subscribe to help YouTube push this tutorial and entire series to more aspiring game developers. And now let's begin. Okay, so to get started with creating our bat enemy, we're going to first create the scene of our enemy. So to do that, we're going to go over here to create a new scene. We're going to click on another node, and we're going to end up adding in a character body 2D. Now, this character body 2D is going to be for our bat, so we can just name this our bat enemy, right? Because later on in the series, we're going to end up creating a frog enemy as well. So let's make sure that these are separate. And then for our bat enemy, we're going to need a couple different things, right? We're going to need an animated sprite. We're going to need a collision shape. We're going to need a timer to control the different directions in our randomized movement, because today we're going to go over randomized movement, and we're also going to go over player following movement. And then later on in next episode, we're going to go over how to create hitbox, deal damage detection zones, and things like that, so that we're able to create a combat system, because that's what we're going to work on tomorrow, or in the next episode, which is most likely going to be tomorrow, right? So animated sprite 2D. If we add in an animated sprite 2D, then we're going to first start off with creating the animations, because animations are necessary. We're going to need them. They're not too fun to set up, but at least for the bat here, they are pretty simple, and we don't have too many. But the thing is, we are going to be creating a bunch of animations that are not going to be used today, right? We're going to be creating an attack animation. We're going to be creating a death animation. And then we're also going to be creating a hurt animation. And we're also going to be creating a fly animation. So the attack, death, and hurt are going to be used tomorrow in our combat system, right? So our enemy's going to be able to attack our player. It's going to get hurt from the player, and it's going to end up being able to die. So that's going to be next video. That's going to be next episode. So stay tuned for that, because that's going to be pretty big to our enemy. These two tutorials are basically enemy work, but this tutorial here is going to be the movement behind the enemy. So if you're trying to create a flying enemy for your game, then this is going to be perfect for you, because that's what we're going over, right? So let's start off by creating the flying animation. Let's click on this little grid here. Let's go to if we go out of here and you see that these are our main folders in our project, we can go to our art, we can go to our bat enemy. Then we're going to be using the standard bat. You can use any bat you want here, but I'm going to use the standard bat. And then we can use the standard flying, which is going to consist of 4 frames. We can click on these in order just like that, add 4 frames. And if we zoom in on our bat here, this is going to look like a flying animation. We want to make sure that this is looped as well. Okay, so let's create the hurt animation. Hurt animation, we can click on it. We can click on this little grid. We can create the hurt. This is also going to consist of 4 frames. But hurting the bat, we don't want it to keep looping like this, right? We want it to play once and then stop. So we can turn looping off, and that's going to look good. Like the bat just got hurt, and then we go back to flying, and it's going to look pretty good, right? Okay, so now death. We can click on this grid. We can go up here, and we can click on death here. And death is going to consist of 7 frames, just like that. We can put those in order. And again, death, we do not want that to loop, so we can turn looping off, and that is our death animation. Then for our attack animation, we can go up here, click on standard attack. It's going to be 1 vertical, and it's going to be 6 horizontal. And then if we click on these in order, add these frames, make sure we turn looping off again, and then click play, you're going to kind of see our attack animation. So that is our attack animations set up. Now our bat, we can save the scene by going Control S, save the scene into our scenes folder. Now keep in mind, our bat, we're going to need some type of collision, because this collision is not going to act as a collision towards the player, because we're going to go over custom bat collisions that are going to be within our stage scene later in this video at the end of it. But this collision that we're adding right now is going to end up being, let's make sure we have it on the flying animation so we can kind of see how that bat's going to look for the most part, most of the time, right? And we want the collision to kind of be as big as the bat is, including the wings. And this is because this is going to stop the bat from, or this is going to make the bat collide with other bats, so that the bats don't overlap each other, so it doesn't look like there's 10 bats in 1 pixel, right? So this is going to keep the bats kind of separated, and that's kind of what that collision shape there is for. And this collision shape here is also going to act as a collision to the bat only collisions that we're going to end up adding later. And this is all going to make much more sense when we go over that. But that is our enemy scene setup. Now I want to move into more of the movement for our enemy. Let's create some randomized movement, some just state machine movement that's going to completely be randomized. And then we'll go over how to make our enemy follow our player and all that. So let's move into movement. Okay, so to get started with the movement, we can come up here to our bat enemy and we can add in a new script. We can just name this bat enemy.gd and we can create this scene. Let's go down here into our file system and make sure we save that into the scripts folder, just like that. And then let me zoom in so we can see everything. First of all, let's remove everything that's already in this script because we're going to start from scratch. And we're going to start off by creating some variables, right? So some basic variables that we're going to need is a speed variable, right? So a speed, we can just set it to 30 and we can always come back and change it if it doesn't look right later. And then we're going to have a variable for our direction. And something I want to go over here with direction is that we're going to end up having two different ways to change our direction, right? And that's going to be decided basically if this variable that we're about to create is equal to true or false. So we can say is bat chase equal to true or false. We'll just make it a boolean now and we'll set our value for it later. But basically, is bat chase. So if this is equal to true, then we want our bat to chase our player. If it's equal to false, then we want our bat to free roam, right? So that's what we're going to set this here for, because we're going to have two ways to get this direction variable, because that's going to end up playing a factor in our animation. But let's create the randomized way to get direction. So to do that, we're going to have a timer and it's going to end up choosing a random wait time, and it's going to choose a random direction, either right, up, left, or down. And then it's going to set the direction to that, and then we're going to move based on the random direction that we selected. But when we do the enemy to follow the player, we're going to end up setting this direction manually. We're going to be setting this direction manually based on where the player is located to the enemy. So basically what we're about to create is going to be turned off if bat chase is equal to true. So if bat chase is equal to true, what we're about to code is not going to function. But I'll walk you through everything later on in this video once we have it all set up and it's like right in front of us so we're able to see it. But let's create a timer. Let's go to node and let's create a timeout. Let's send this to our bat enemy script, and in this little timer here, we can just get our timer and then we can say wait time is going to be a random number. So to do this, basically what we're going to do is we're going to set the wait time of this timer to a random amount every single time. So maybe we want to be going right for 2 seconds and then we want to go left for 1 second, but we want it to all be randomized. So to do that, we can change the wait time of our timer. So we can say, okay, well, wait time equals choose, which is going to be a function that we have to create. It's going to be a little logic function, and then we can say maybe 1, 5, and 2. So we can choose from these times. And to do this, we can come down here and we can say function choose, and this is we're going to pass through an array just like this. And then with this array, we can do something like a little logic function, which is array.shuffle. So it's going to shuffle the values within this array, and then we can grab whatever value ends up at the front. So we can say return array.the front, right? So then this is going to send back a different wait time. So we spelled this wrong here, but that is array. And then we're also going to end up using this to choose a direction. So let me show you how this works. So if we come up here and we say, okay, well, let's check if the bat is not following the player. So if is bat chase is equal to false, then that means that the bat is not following the player and we want the bat to free roam. So then we want to grab a random direction. So we can say, okay, well, we want our direction to equal a random value, and we're going to choose that value randomly by using our choose function that we just created. And we can say, okay, well, vector2 dot right, and then we can use vector2 dot up, vector2 dot down, vector2 dot left. So we can say, okay, well, we have vector2 up, and then we have vector2 left, and then we also have vector2 down, right? So what this is going to do is this is going to choose a random coordinate. It's going to either choose 1, 0, or -1, 0, 0, 1, 0, -1, right? So to test this out, we can actually go here and we can say, okay, well, let's print our direction and let's see how this works. So if we create up here and we create a ready function real quick, let me show you, just so we can set our bat chase. We can say, okay, is ready, and then we can say bat chase is equal to true, and or I guess bat chase is equal to false, so we can free roam. We can say, okay, well, we need our timer to auto start as well. So we can go to the inspector and we can tell it to auto start. And let me walk you through how this is going to work right before we do it. So we have our speed direction. The speed does nothing now, but bat chase is equal to false on start. So, okay, bat chase is equal to false. Then our timer is going to end up timing out after 1 second because that's what it's set to. And then it's going to set the timer's wait time to a random number either 1 second, 1.5 seconds, or 2 seconds. And then it's going to check, okay, is bat chase equal to false, which it is. Then it's going to use this choose function here. It's going to choose a direction because it's going to say, okay, right, up, left, and down. And then it's going to shuffle those around. So maybe left will be in the front. And then it's going to return the front. So, okay, it's going to say direction is going to equal up. And this value right here, remember, vector, or let's say vector 2 dot right here, this value here is equal to 1, 0. That is what this is equal to. And then this is going to be equal to -1, 0, right? And then we can print direction. So we're going to end up printing whatever we get, whatever this is equal to. So if we click on our bat scene and we click F6, you're going to kind of see how this works in our output down here. It's going to print a random direction every randomized seconds, right? So it's either 1 second, 1.5 seconds, or 2 seconds. But you can kind of see it's all Y's. I don't know why that is. That's just coincidence. But you can see there's an X value. And it's basically picking a random direction. So now we are choosing a random direction for our enemy to move in. So that is how that is going to work. And then we're going to create a move function. So if we create a move function, we can make the enemy move by timesing our speed and velocity by, whoa, I cannot spell delta. So delta, just like that. But it's going to end up times just like a normal movement. First of all, if we're moving, we want to check, okay, well, let's recheck, is bat chase equal to false? If it is, then we can say, okay, we want our enemy to move. And we're going to use the direction that we just got. So we can say, okay, velocity plus equals direction times our speed at the top. And we can also times that by delta. And then we can create a move and slide function here, just so our player does move on the screen. And then if we go to our stage scene and we instance our bat, just so it's a little bit more zoomed in, just like this, and then we move our bat down here next to our player so we can see it, and we click F6, what's going to happen is you're going to see that our bat here is not moving. So let's figure out why the bat is not moving. We are choosing a direction, but our bat isn't moving. So if we go back to the script, we can say, okay, well, we say, is bat chase equal to false? And it is. Then we can say velocity plus equals direction times speed times delta. But because look, we're never calling our move function. So to do that, we have to say, okay, function, and we can create a process function because we don't even know what delta is. So we can say, okay, process function, and then we can just call our move and we can pass through delta just like this. And then now everything should work. So now if we go to our station, click F6, you're going to see that our bat is going to move in random directions based on what the direction it chooses. And it's moving pretty quick, and it just left the screen. But that is because we don't really have any control over which way it moves, which we haven't created that yet. We just have some basic movement, but you can kind of see how it moves in random directions. It just kind of moves around. And this is going to look better once we have animations and the sprite flips based on which way it's moving, and we have collisions and everything like that. But that is some movement. That is some random movement. Now let's go and let's add the animation so it actually looks right? So to handle our animations, what are we going to do? Well, we're going to go into our process. Let's create a new function. Let's say, okay, handle our animations just like this. And then we can create this function down here. And this function is going to say, okay, well, function handle animations. And what do we want to happen in here? Well, first, let's get our animated sprite from our scene tree. So we can say, okay, animated sprite is going to equal our animated, it's going to equal our animated sprite 2D, just like that. And then we can say, okay, well, what do we want to happen? Well, our bat right now, as of current in this video, is only going to have a flying animation. So to keep this simple, we can just say animated sprite dot play, and then we can say fly, just like that. But we also want to flip the direction of our enemy. So to do that, we're going to say, okay, direction dot x equals -1. Or if direction dot x equals -1, then we can say, okay, we want our animated sprite dot flip h to equal to true, right? Because that means we'll be moving left, and we do want it to flip. And then we can say here, we can say else if direction dot x is equal to 1, then animated sprite dot flip equals false. Now if we go to our stage level, we should have animation. So you're going to see that it's flying, it's going this way, and then the moment it comes this way, it's going to turn back. It's going to hit the ground, but this will be fixed once we add the bat only collision, so it won't fly right here. It'll only fly about at this level. But you can kind of see that the bat is moving. It's going in weird directions, but that's just because we are moving at random speeds, and we can always change the speed down a little bit if we wanted to. But That looks right. That looks good. The player or the bat moves at random directions in random ways, does random things. It's hitting the ground, which we'll fix that. But you can kind of see how the bat is flying around. Maybe the bat's going to switch directions, maybe not. Maybe the bat won't switch directions. I don't know. We'll see. But you can kind of see that it's kind of hard to control this because it's just a basic randomized movement. But it'll look so much better once we have our player movement in. Okay, so let's go and let's add the player movement so we can make this look a little bit better. So to do that, we're going to end up creating some follow player movement. And to do this, we're going to go into our global script so we can get the player's body. So we can say, okay, well, var player body is going to equal a character body 2D. And we need to set this script from our player scene. So we can go to our player scene and we can, in our ready function, access that. And we can say, okay, well, we want global dot player body to equal self, right? Because this is our player script. Then we can go back to the bat script. And in this script, we can go down here into the move area, into the move function, and we can say, okay, so if bat is not chasing an enemy. But okay, what if we said, or I mean, if is bat chase is equal to false, but what if we wanted, okay, well, if is bat chase is equal to true? Well, that means we want to chase our player. So we can make this into an else if, and then within this area here, we can say, okay, well, we got to create a variable. So we can come up here to the top and we can say something like var player, and we can equal it to nothing for now, or we can just equal it to be a character body 2D. And then we can come down here into this function and we can say, okay, well, we want player to equal the global dot player body, just like that. So now player is going to equal global dot player body, so it's going to equal our player. And then we want to get the position of our player and move towards it. So we can say, well, we want velocity to equal the position dot direction to, so it's going to get our bat's position and it's going to get the direction to our player position, right? And then we can move at that at the variable of speed, just like this. And you're going to see that this is going to work, but there is going to be a problem with it. Or I guess it's not going to work yet because we didn't go up into our ready function and set our bat chase to true. But there is going to be a problem with this, and I'll show you why. Because like the animations are all messed up now because the animations are following, but you can kind of see how it looks like it's actual player and enemy movement, and it follows the player just like that. But you can kind of see how the animations are messed up, and I'll tell you why this is. Well, this is because if our handle animation here, the direction is never being changed. Up here, the direction is never being changed because the direction, there is no direction. It's set to based on where the player position is. So the variable direction is never being changed. So we have to change it manually. And to do that, there is a way to do that. Let's remove this print statement down here so we can kind of see what's going on. And then up here, we can say, okay, well, let's use some logic and let's kind of think about this for a minute. Well, if we have velocity.x, let's say velocity.x is equal to -30, right? That means we're moving at 30 into the left, right? Going left. And then let's say, okay, well, what if we got the absolute of this, right? Okay, so let's get the absolute and then let's divide it by itself, which would be -30. That's going to equal -1. So it's going to return -1 if we're moving left, which is the direction that we need. Or let's say that we're moving 30 right and then we divide it by itself. Well, what's going to happen, right? Then it's going, the absolute of 30 here is going to be 30 again, and then we divide it by itself, it's going to equal +1, which is going to mean we're moving right. So to test this out, we can get our direction by saying the absolute of velocity dot x, and then we can divide it by velocity dot x, and then we can kind of see what that prints. So if we click play, basically, if it's following our player, you can kind of see that it says -1 down here in the output. We go this way, it says +1. So if we manually set our direction to this logic function, then it's going to set the animation correctly. So we can say something like direction dot x is going to equal the absolute of velocity dot x divided by velocity dot x. And you're going to see that now our animations work good, and it looks like the bat is following us just like that, and the bat does follow us. Now I want to go over some collisions, but I also want to go back to going over some of the enemies. If we come up here and set bat chase equals to false, you can kind of see that, okay, well, now it's not going to follow our player. Now it's going to be free roaming. So it's going to come down, it's going to go up. Maybe it's going to go up too high, but it's going to move around. And we can always fix this by going down here into our wait time down here and setting these variables. So maybe we want to do maybe 0.5 and then 0.8, and then we can just try those so that we have only 2 times to choose from now. But if we go to stage level, we can kind of see how this is going to work. So now it's going to switch directions quicker. You're going to see that it's flying. So you're going to see that our bat does move in more of a random way. But he's hitting the ground, and the ground's an issue because the ground's going to mess it up. So we're going to end up adding a polygon collision here. But you can see that the bat is flying. The bat would probably be moving down there. I don't know where he's going exactly, but he is on randomized movement. So it looks like he's flying around randomly, which looks pretty good. So, okay, that works, right? Now, I want to go over the collision shape so we can keep the bat off the ground, and then we're going to have to go over collision layers and collision mass. So to do this, we can go into our stage level, and we can end up adding in another static body 2D. Just like this collision shape here, we can name this static body a bat only collision, just like this. And then within our bat only collision, we can just add in a collision polygon 2D. And to create this, we got to think about where do we want our bat. So we can start it here, right? And then we want our bat to not go any lower than like this area, right? Because this is where the player's head's going to be. So we can, I don't know, put a point there. Then we can come all the way over here to the end, and we can put a point here. And then we want maybe our bat to follow this wall. We don't want it to go past this wall. And then we can come up, and we want our bat to go above the camera, of course, so it looks like it can fly off screen. Come back around, and then we want it to start to come down here, so it can't go too far this way, like this. And then we can come down, but we do not want to click it here, right? We do not want to click this. Instead, we want to come out this way, and then we want to loop back around so that the collision is going to fill in a certain way, right? So now you can kind of see that the collision fills in this way. So we want our bat to be trapped within this area. And then up here, we can move this a little bit. I accidentally added 2, so we can kind of move these around just like that. And then this is going to be where our bat collides. But the thing is, if we click play, what's going to happen? Well, our player is going to end up colliding with that as well, which is not going to be good, right? So we do not want that to happen because I'll tell you why. That doesn't look right. But we do want our bat to collide. This is where we want our bat to collide. So to fix that, we can change in the layering and mass. So we can go to our bat only collision static body here, go to collisions, and we can set the layering to 2 and the mass to 2. And then you're going to see that if we click play, that our player will no longer interact with that collision. But our bat now also won't interact with that collision because our bat doesn't, our bat is set to 1 and 1 as well. So if we go to our bat enemy, we go over here to collisions, and we set the layering of our bat to 2 and the mask of our bat to 2. And then we go to our state, our bat enemy script, and we come up here to the top, and we set bat chase to equal to true. That means it's going to chase our player. We can click on stage level, and then what's going to happen here is the enemy should chase us, and you're going to see that it stops there. It doesn't hit the ground, so it looks more, I guess you could say, legit. It looks more like the enemy is actually chasing the player and not like rubbing against the ground. But you can kind of see how the enemy interacts with this layer, but the player does not, and the player can just run through. So the player also doesn't interact with the bat, because we don't want the player to just be like able to stand on top of the bat or something like that, because that wouldn't look right? But this is how this works. And then you're also going to see that if we go to our stage level and we insert another bat, that this bat enemy is not going to collide with this bat enemy is going to collide with our other bat enemy, so they don't like overlap on top of each other. So it looks like they're flying next to each other and not on top of each other. So hopefully this video was able to help. Hopefully this tutorial was able to explain some things about enemy movement. Hopefully you were able to create some enemy movement. If you want to see the complete script here, maybe you'd have to zoom in on your computer, but this is the script here. And this is kind of what we went over today. So I hope that this video was able to be helpful and you were able to learn something here today and about player movement and our, I guess, enemy movement. But remember, next episode we're going to be going over combat. So our player and our enemy are going to be able to fight each other, and we're going to have hitboxes on our player, hitboxes on our enemy. We're going to create enemy attack animations. We're going to create player attack animations, and it's going to be a whole thing. So I hope this video was able to help you out. Thank you so much for watching. I really do appreciate it, and I really do hope that you are having a good experience within this series. This is episode 3. We're going to be moving on to episode 4 tomorrow, so that should be amazing, and we should be able to, it's going to look more like a hack and slash game tomorrow once we have some combat in here, so that's going to be exciting. But I want to thank you for watching. So now these enemies are both on randomized movement. They are just flying around however they want to, and it looks pretty good, right? So that is how we are going to be creating movement. And then if we go out here and we set our bat enemy to true one more time, you're going to see that this works. But remember to subscribe, hit that like button to help you to push this series to more aspiring game developers so they can also learn to make their own Godot games as well. I want to thank you so much for watching, and until next time, stay safe and have a wonderful, wonderful rest of your day. Bye-bye.